Welcome to the second part, logical operators. It's when our questions become a bit more complex where we need to utilize this. What I mean by this? Let's say for an example, the sky is blue. Also, I have a basketball or a ball or a cricket ball, whatever it is. If the sky is blue and I have this ball, well, then I could go outside and play with my friends. But in the case that one of these are false, such as let's say I don't have a ball, well, it doesn't matter, the sky is blue, no one's going to come and play with no balls. If I have a ball, but the sky is raining, it's gray, it's dark, it's snowing, well, again, I can't go and play this sport I want. So in this case, I need to have both sides true to be able to do something. So my questions are becoming a bit more complex. To be able to do these questions, I need to be using these things we call logical operators, such as the keyword and. If the sky is blue and I have a ball, then I could go outside and play something, right? To be able to do these, to be able to do multiple relational operators together, we bind them with these logical operators, right? It allows us to have a sequence of relational operators, as many as we want. What are these logical operators? Well, you've seen one, and that's AND, represented in Java with a AND symbol. In different languages, you might also see the word AND, especially if you go in JavaScript. That one, it's a bit more funky. We're not going to talk about it now. And another one that's important for us at this level would be the OR, represented in Java with two pipelines. Okay, the pipelines are basically at top of your enter key. You should see it's a straight line. It's not the letter L or the letter I in capitalized. It's not that. It's a character of its own. It's a pipe. You should see it on your keyboard. Now, if you want to do these relational operators, you use the symbol representing them. So let's try this out. So let's say, again, we're going to create two variables. Let's say this time A, and it's 100. Or actually, let's make it a bit more interesting. We have sky is blue and have ball. This is my example I utilized, so let's utilize that. I'm going to say a boolean to represent the sky. Is sky blue? And for me, currently it is. So it's pretty nice right now outside, and I'm stuck inside. And we got another one to represent if I have a ball. I'm going to say have ball. And I'm going to say true. Right? These two variables are representing the state of the sky or the state of me having a ball. This is important. Now, we need to figure out if I could go outside and play basketball, cricket, whatever it is. So can I go out? Well, let's make it simpler. Play outside. And this is my question. Now I have to pose these two types of questions. First, we say, is the sky blue? So is sky blue? And then I have another question needed for me to play outside. So here we need to say and. Do I have a ball? Based on both of them to be true, and only then can I go play outside. This is the key for ends. We could, well, actually, before we go further, let me go ahead and draw you a little table. I'm just going to pause it so you don't have to. So here I drew out a table that shows all the different possibilities of these two questions. So question 1 and question 2. The first possibility is that both of them are true. What would happen? Well, if both of them are true, well, then I could go play outside, right? So the end will be true. If the sky is blue and I have a ball, then go play outside. The second one is saying question 1 is true, question 2 is false. If the sky is blue and, well, in this case, I don't have a ball, and I have a ball, but I don't have a ball. So I cannot go play outside, right? I can't go play basketball without a ball. So this becomes false. The moment one side is false, well, then the result is false. You need both for it to happen. As an example, I need to have a job and I need to get paid for me to go work, right? I can't work. Well, I will not work if they're not paying me. And I can't work if I don't have a job. I need both of those things for me to go work, as an example. It's a bad example. Let me pick another one. It's fine for now. So let's try it again. So now if the sky is false, right? Third line. If the sky is false, but I do have a ball, well, I'm not going to go in the snow and play with my basketball. The ball is going to be wet. It's going to be disgusting. It's not fun. So again, I won't be playing outside. And in the case where the sky is not blue and I don't have a ball, well, I'm not going to go play at all. It's impossible. I don't have a ball and the sky is, right? Now, the key thing to get from this, inside of an AND operator, only is true when both sides are true. Okay? Now, let's make this a little bit more complicated before we go to the OR. We've learned a lot of cool things. So, let's say play inside. Okay? So the first one was to play outside, but the second one is to play inside. Well, obviously, I'm going to play outside if the sky is blue. But if the sky is not blue, well, I could go inside of a gym and play there. So here I could say if the negative of is sky blue, so not sky blue, so the sky is not blue, and I have a ball. Now this gets a bit more interesting. This needs to be done before this. So this relational operation needs to be done before this logical operator. So in this case, I'm inversing. Let me go and make this into a different color here. I'm inversing Q1. I'm going to do it here. We're saying actually, I'm going to write Q1. And then right beside it, we're going to do the inverse of Q1. And over here, we got our question 2. And I'm just going to do it like this. So it's a bit more, sorry, I'm not a best drawer here. I just wanted to do something a bit to tell you this is the end result, okay? So what would that mean? Sorry for my handwriting again. Let me make this a bit better. So let's redo all the possibilities. So question 1 is true. Question 2 is also true. Question 1 is true. Question 2 is false. Question 1 is false. Question 2 is true. And lastly, question 1 is false and question 2 is false. So this is all the possible results, all the possible scenarios that could ever happen, right? The sky is going to be blue or it's not going to be blue. And with all the possibilities of having a ball or not having a ball, right? Now, before we do the end part, we're not really interested in question 1. We're interested in the inverse of question 1. And that's this one over here. The not question 1, which basically inverses whatever we have. So true becomes false. True becomes false. Notice it's becoming the inverse. False becomes true. Let me just... And false becomes true. Notice we just inverse whatever the values are. So now we're not so interested in this side. We're more interested in this guy and in this guy. Right? So not question 1 and question 2. So the sky is not blue. That's false. It is blue. And I have a ball. It's false. Right? Why? Well, we have one false on one side. It's automatically false for ends. The sky is not blue, and I don't have a ball. In both cases, I don't have anything. I can't play b-ball. So this is false again. The sky is not blue. So this is true. Remember the not over here? So this is true for us. So I'm going to go play inside. Do I have a ball? I do. So this is true. The last one, the sky is not blue. So this is true for us. And I don't have a ball. So I can't play either way. I don't have a ball. So this becomes, this becomes false. Notice again, with the AND operator, with this logical operator, AND, we only have true when both sides are true. Cool? So let's make sure that what we said is actually what we want. We're going to print it out to the screen. Play outside with ball. And we're going to concatenate it with play outside. We're going to copy this. And we're just going to say play inside. So let's run this and see what happens. So remember that both are currently true. So notice that when the sky is blue and I have a ball, well, I'm going to go outside and play. What happens if the sky is not blue, but I still have a ball? Well, this time, notice that playing inside will be true and playing outside will be false. What if I don't have a ball as well? Can I play inside or outside? In this case, you'll notice again, we're not going to play anywhere because without a ball, how can we play? Right? These are the questions we're asking. And you got to remember that we could ask many questions of any variation. So let's make this a bit more interesting. So let's go down. So remember those parentheses? Well, we could utilize them again. Well, actually, let me put them all together here. Boolean. Can I just play inside or outside? I don't care. I just want to play. So can I play? Well, this could be pretty easy. We could just say you have a ball, you could play, right? But let's utilize our two questions already posed. I could play outside or inside, and they're given to us by these two values. So what I could say is, can I play inside? Or, so this is the or, can I play outside? Either case, I could still play. So let's print that out. Can I play outside or inside? And we're going to just say play. In this case, until one of these is true, we could play. So right now when I run it, it's going to give me false because both of them are false. The ball itself is missing. The moment I change the ball to true, it doesn't matter if it's inside or outside. This is going to be true. Right? Play around with this. Make sure that whatever you have in your mind, whatever you think, is what it displays. Because the computer is not going to change. Most likely, the errors are always programmer errors. 99% of the time. Now, let's make this a bit more interesting. Actually, before we make it interesting, we talked about the OR logical operator. So let's go ahead and create the same table we've done for the end over here. So now it's a bit different. First of all, our question 1 and question 2 is not the sky is blue or have a ball. It's line 10. The question is play inside or play outside. So these are not our questions. Our questions are going to be play outside, question 1, or play inside, question 2. Right? So the result of play outside or play inside is going to determine if I'm going to play. So here we have an OR, right? The symbol for OR. And we're going to ask ourselves, OR is pretty easy. Until one of them is true, then it's true. So if I play let's say it's possible to play, what's our question one? Play outside. It's possible to play outside and, well, sorry, I shouldn't say and here. So let's say play outside is true, play inside is true. Well, then it's obviously going to be true. I could play either way. They're both true, right? I could play either outside or inside. Hurrah. What if I could play outside, but I can't play inside? Well, I could still play. So it's again true. What if I can't play outside, but I could play inside? Right? Again, true. Until one of them is true, it's true. Lastly, I can't play outside, nor can I play inside. Well, in this case, it's going to be false. I can't play outside. I can't play inside. Can you play outside or inside? No. Then it's done. False. So this is the logical operation table, right, for the OR. There's a few other ones. For now, we're not going to discuss them, but and and OR, you're going to utilize them a lot. Let's go ahead, clear our screen for a second. We're going to clear just a little bit, actually, just so it's going to be less messy. And let's go ahead and make this a bit more interesting or a bit more complicated, let's say. Now, the same way with any math operations, the logical operators, you could make as many as you want. There is an order to this, and the order is basically and always will be done before ORs, so you got to be careful. What I like to do is maybe surround them with parentheses at the beginning so we make sure we don't make mistakes. What I mean by this, let's go ahead and make this a bit, I'm going to just go down here, and we're going to create a couple booleans or questions and whatever. So we're going to say A is true. I'm going to create another one. B is true. And let's create another one. C is false. And maybe a third one, which is false. Okay? 2 true, 2 false. Let's see what we could do with that. And we're going to create a complicated, we're going to create a complicated question. Now, these complicated questions could be really weird. Let's try something out. So let's make it something simple, A, and then we're going to say and. So this is an and. We require both sides to be true. Let's say one side, well, let's make it easy. A and B or C, right? So let's see what's going on here. So we got A, which is true. We got an and over here. We got B, which is also true. And we got C, which is false. Now, the rule that it goes is ends are done prior to all ORs. So here, both of this will be done first. True and true will give you true. And then we got the true or false, which is done after. So we should get a true. Let's run our application. Now, this is important to keep note of what comes first and what comes after. We didn't output it to the screen. Complicated question, run that. Notice here we got a true. Perfect. Let's make this a bit more complicated, and let's see if you guys are following along. I'm just going to erase a little bit, and let's go ahead and change that code that's being shown here. Rather than A and B and or C, well, before we make it too complicated, let's just inverse the logical operator we're utilizing. Oops. So over here, we're gonna, before we run it, we're just gonna determine what is what. Where's my pen? There we go. Again, we have true, or B, which is true, and C, which is false, right? Now, what should be the end result of this? Take a moment, figure out. But we've talked about this before. The end is going to be done first. So we got true and false, so we get false. And then we're doing the OR operation. So true or false, which will give us a true. Hopefully we're right. Yeah. Right? Even though we moved this around, it still gave us true because the OR operation is being done last. And A was true. Okay. It seems to be pretty clear, pretty straightforward. Let's try this a bit more funky. Let's go ahead and erase these. So now I just need to think about this for a second. So we're going to grab a D and then we're going to put an end. And then we're going to say, I don't know, let's say a C. Then we're going to put an OR. And we're going to grab an A. And then we're going to say another C. What is the final value? Again, if you need to make this into a table, we could also do that. So we got D. This is going to be a bit big, but actually let me clear off a bit more of my screen. We don't need these anymore. Logical operators, make our clean screen, our real estate. So here we go. We got D and C. We got an OR, A, and I should probably move all of this. Give me a second. Let's make it a little bit cleaner. D, and C, or A, and C. Now, before we could go downwards, we should create all the possible options of A, C, and D altogether. So the first possible option is that this is true, this is true, this is true, and this is a repetition of that. So for now, I'll leave it blank and we'll copy it right after. C and C should be the same. It can't be that one C is different from the other C. It doesn't make sense. It's a variable. The value is always constant at that execution time. Then we have the possibility of true, true, false, right? We're transitioning one by one. True, false, true, true, false, false. Then we got false, true, true, false, true, false, 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 true. And one last one, false, false, false. Notice how I went through it as a sequence from right to left. It's an easy way to remember you've done all the possibilities. Okay? And the C is going to be a repetition. So true, true, false, false, true. I'm just repeating the column of C that's already there. The value doesn't change. Let's go ahead and change some colors. Actually, first let me do some lines. Okay, I can't do straight lines. Don't blame me here. Blame my art teacher. Wasn't a good teacher for art. I'm just messing around. And let's make some lines right there. I should have paused the video and just went forward with this, but you're with me. You're giving me a good experience. Someone to talk to while I go crazy. All right. So now that we have this table, we need to figure out which one of these I do first because they're going to determine the other one. And as before, we said there's the same thing as math. There's an execution order that's going on. And the execution order is ends are always before ors. Now, if you don't want to be mistaken in this, utilize parentheses, which is always higher than both of them. Actually, let me make this pyramid a bit bigger. So we said at the bottom it's always ors. Then we got ends, And if we want to make sure that we don't make any mistakes, we could utilize parentheses to make our lives easier, to make it visible, more readable, etc., etc. Now, so ends are first, so D and C. So true, true. One side is false, 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 false. Anytime you see a false on one side, it's false. Only true when both sides are true. The or over here, well, first of all, this is done. So I'm not going to utilize the C. We're going to utilize the end over here, the result. But if you look at the other side, there's an end that hasn't been utilized, that hasn't been done yet. So we need to do that first before we touch this or. So let's go do this end over here. A and C. So again, both sides true, it's true. Otherwise, it's false, 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 true, false, false, and we got false. Right? So we only got 2 truths here, and we only got 2 truths here. Now we're at the or over here. The or, we're going to compare this one to this one, right? Nothing else. So let's go ahead and take another color. I'm going to do it in red. So again, we're comparing this and this for this or. So true and true equals, true or true will equal to true. True or false equals to true. As soon as there's one true, you could ignore even looking at the other side. This is false or false, so false, false. So in the or operation, it's false when both sides are false. So in this case, it's true. One side is true. This is false, false, false. So these are the possibilities of it to be true. There's 3 parts that's possible. Everything else is false. So why don't we try that in code? So we already have the first possibility. In this case, we have D as false. So we're looking at these ones at the bottom here. Let me draw that one more time. So the first one, D, is currently false. So we're looking at these possible ones. And then we got C, which is currently false. C, which is false. So we're looking at these possibilities. We're at 2 possibilities. And notice that these 2 possibilities, the end result is going to be false. So if I don't even need to look at the last one, we already determined that it's false. So if I run this, this is going to give me a false. You could see that here. When can I make this true? Let's see. So we got a true here and 2 here. So it's true when all 3 of them are true. So D, C, and A. True, true. And we run it. Where's my run? True. We have it true if A is false, but the other 2 are true. So this is false, but the other 2 are true. Right? We don't care about A until one side is true. We don't care about the 2 middle ones or either side. Until actually the better way of saying this is until one of the ends, one of the sides of the or is true, we don't really care about the other side. Okay? And you could try it out with these other results to see if it matches what we needed. Now, coming back to what it was by default, we could change this answer. So currently it's false. We could change this answer by enforcing some parentheses in there. So we could change this answer by saying, you know what, the C and the A are going to be done first. The parentheses ensures that this or is done before the ends. So now if I run it, I don't know what the result is. I'm not really looking. But if I run it, it's still false. But the operation that's happening has been changed. We first say C or A. C is false, A is true. So this Let me clear my screen. So this basically, so C, okay, so let's try this out. C is false, or A is true, D is false, and C is false. This is a lot of false. But first, these two happen because they're in parentheses. They have a higher priority. So this false or true will give you true. And then we're talking about ends. As always, we start from the left if they're at the same priority. So ends are all the same priority. We do first the left side. False and true will give us false. And then we do the last part, false and false, which will give us also a false. Right? It didn't change much because of what the values are there. Let's clear the screen. So what can make this true? Well, it's kind of hard when both ends of the end are false. So maybe we'll change one of them to, let's say, true. Right? This D is true. But this C is still going to give us a false. So what can we do to, well, it really has to be changed. Ends require both sides to be true. Right? If we want to make it true as an example, there's no reason to do it. Actually, there is no reason. I don't want to give you that bias that you kind of need to make it true or something. That's not what we're looking for. What we're looking for is to make our questions more complicated and to ensuring that the correct question is asked first or after, right? So this is a really important thing. This is our logical operators. This is the part 2, and we're going to utilize it in the next part, which is really important. So I'll see you there.